we have this polynomial here, quadratic, 55x squared minus 373 plus 630. So this is a wild and big coefficient, like all of them are big. Unfortunately, this one has no common factor because this is 55. The factors are either 155 or 5 and 11. Given that 5 is quite easily to find, this is not a multiple of 5, not a factor of 5, even though this is 11. This is not a multiple of 11. 660 is, but 30 less is not. 33 less is close, but not. So, no, we don't have any. So what do we do? Well, we have to go through the factors of 630. Yes, the obvious one is 630, but how many more are there? How many more pairs are there? So we have to use prime factorization. 630 is 2, 3, 3, 5, and 7. Those are the prime factorization because it's 90 times 7. So, or 70 times 9. 2 times 5, that's 10. 70 times 9, that's 630. And that will be one pair that we'll come across. So let's, using this to help us write out the factor pairs of 630. 1, 2, 3, is 210. There's only 1, 2, so no 4 or multiples of 4. So we'll skip those. 5, this will be 126. 6 is here. It'll be 105. 7 is here. And we said that is 90. We're back to 2 digits now. And then 8 is a multiple of 4. We skip. 9 is here. And it will be 70. Now, we'll start writing next line. 10 is 2 and 5. And it will be 63. 11 is a prime, we'll skip. 12 is multiple 4, we skip. 13 is prime, we skip. 14, 2 and 7. And we're 45. 15. We have 42. 16 is multiple 4, we skip. 17 prime, we skip. 18, 2 times 3 times 3. 19 prime, we skip. 20, even if it's multiple of 4, we also skip. 21 prime, we skip. No, sorry, 21 is here, not prime. And this will be 30. 22, multiple 11, we skip 11, so we're skipping that. 23 prime, we skip. 24, multiple 4, we skip. 25 is only 1, 5, we will skip. 26 is a multiple of 13, we skip 13, we are skipping this. But we should stop there because eventually we should get back to 30 and get 21. And we should stop at 26 because 25 squared equals 625. So that's why we should skip. We should actually stop at 25 because the smallest, the closest pair of factors is your square root. So this is 25, so we don't have any more integer factors other than those. So now we look at this really long list of factor pairs and then we try and figure out what to do. We're going to skip the 1 and 55 and 1 and 630. In fact, these are not good pairs to start with because this is 600, this is 50. It's not close to it. And also, this is a negative, so that means all my factors here are all negative. So, in case we run out of pairs, because why not? We need to test more, right? We can try 11 and 5 because that's also a pair of factors of 55 as well. We're not going to flip this list upside down because if we flip one side, we don't flip the other side. We always pick the shorter side to flip in case we run out of pairs of factors. Now we're going to start trying. Once again, we're going to skip the 155 because 55 times any number more than or even less than 10. At 10, you'll be at 500. It'll be really hard for the 1 to get back to 300 here. So I would not recommend using this pair. I would recommend finding a pair of factors that are closer together. For example, 5, 11, or 11, 5. And from this end, we also start with this end as well. We pick from the factor pairs that are closer together. So we are going to start with 5 and 11 and 21 and 30. 5 times 30, negative 30, by the way, is minus 150. 11 times 21, that's 231. That's minus 381. Nope, not it. So 5 and 35, that's minus 175. 11 times 18, that's negative 18. 198. That's almost 200. Add that together, minus 373. What do you know? This works. So that means what here? And we can break down the 373 into minus 175x minus 198x. Yes, there's only a common factor of 5 here, 5x here, 11x minus 35. And over here, we need to get 11x, so that means I need to factor out the negative 18. And then I have 11x, and this would be minus 35. Or we always use the short method. Once we get here, it will be top bracket 5x minus 18, bottom bracket 11x minus 35.